Okay, so here we go with the Unit 2, Paper 2 for 2021, May 2021, Unit 2, Paper 2. Question, Section A, Data Structures. With the aid of a diagram, provide a detailed description of a linked list. Alright, so there are 8 marks, so we gotta go from the top, and then we have to write the description. So what they want us to do with our diagram is you must have the head, and the head points to a node. So we want to describe this as a node, and this is the data, and this part is pointer, PTR, pointer. So the pointer points to another node with data and a pointer, and then we keep going until we reach, I don't know, like 3 should be enough. Data, pointer, and this pointer here will point to something called null. Right, once you have that, I believe that you should get 4 marks, because you have to make sure that you put the head in, you have to make sure you put the null in, and you have to make sure you put each pointer pointing to the other. So using the arrows should get you that there. Fairly okay. Alright, and then the description. You want to say what? A collection of elements that starts with a head pointer that points to a node that contains both data and a next node pointer. The last node points to null. Yeah, I believe that's enough explanation there to get here 4 marks. You basically want to say that it points to the next node and they reference each other. Both data and next node pointer. Next node pointer that references the other node. Put that in. The next node. Yeah. Alright, that references the next node. You should be okay there to get our 8 marks. Alright, now under normal circumstances, you're not supposed to ask you to code a linked list, so the most you'll get is a description like that. Alright, define each of the following terms. A stack is an array of elements, array / collection of elements that where data is inserted and removed in LIFO, last in first out. Well, it's only 2 marks, so I guess once you put LIFO inside there, last in first out, that's what they're looking for. And you only have 2 lines, so you really can't go too hard and explain top and all that kind of stuff, right? So a queue is an array / collection of elements where data is inserted and removed using FIFO, first in, first out. Alright. Normally that question will be 2 marks for each, so you could give a lot more information, but anyhow. State two conditions that must exist for the successful execution of insert and delete operations as they relate to stacks and queues. For insert, the stack or queue must not be full. For delete, the stack or queue must not be empty. Yeah, not a lot to write here, but close enough. Alright, going good so far, going good so far. Complete the table below by stating whether a stack or queue data structure should be used. Each of the examples given. What is that? Oh, pause 1 second. Alright, so undo reoperations in a word processor. That will definitely be a stack because it's last in first out. Implement the printer spooler so that jobs can be printed in the order of their arrival. That's a queue for sure. Implement the back function on internet browser. That's a stack because you want to go back to the last thing that was on top. Store customer order information for a drive-through restaurant. That is a queue because you want to be able to get the information. You want to be able to deal with people in the order that they came. And last one is store incoming calls for a customer service hotline in which your calls must be answered in the order. Well, that's a queue. Easy. Now, man, is that a question? When you see questions like this, tell yourself there's some storm coming later on in the paper. Somewhere in the paper, there is a storm brewing. Let's go ahead. Write the C code for the 8 marks. Write the C code for the pop stack operations where a stack is implemented as a fixed size array. Represent your code as procedure such that the stack array stack is accepted as a parameter. Assume not a global variable is used to track the top of the stack and that it is initialized to -1. Alright. 8 marks to write our pop, boy. Alright, there you go. Int pop. We're supposed to receive our int stack. We receive the int stack. And then we will have to now say the value that we want to pop out. So we had to declare it int value. Once the value is there, now we have to do the if. Right, because they told us that top is initialized globally, we're checking to see if top is equal to -1. Yeah, if it is equal to -1, then we want to print out that, do we have to print that as empty? We should print as empty. Printf. Stack is empty. We close that off, and then the else now would be to pop the value out of the stack. So to pop the value out of the stack, you want to say value is equal to stack location top, and then you carry the stack down by 1, so you go top minus minus. Alright, let me put my semicolons because I've often been very lazy with my semicolons. And then you close off. No, then you have to return, because yeah, it's our function. So return value. Yeah, that's all. Yeah. That's all I'll say. Alright, so we should be good there. 8 marks. Where the 8 marks are, probably one font up there. You'll get one for you get one for the type. You get one for the putting in the stack properly. You get one for creating the value there, for checking for if it's empty. For dropping the variable in, for carrying it up down by 1 and returning. That's it there. 1, 2, 3, 4, 5, 6, 7. Oh, one for printing out to appropriate something saying empty. Right there. That should be 8 marks there. Yeah, man. That question wasn't that bad. Explain the function of each of the following search techniques: a linear search and a binary search. Alright, so a linear search traverses the whole array and compares each value with the search value. If a match is found, it returns the appropriate message. The index, or returns the index or an appropriate message. Right. Yeah. Linear search traverses the whole array, compares, and returns the value if it's a match, right? A binary search first finds the midpoint. No. Binary search. Sorry. First thing I'll say with our binary search is the array must be sorted. The array must be first sorted. Then it finds the midpoint. Finds the midpoint of the indexes and compares it with the search value. If the search value is a match, it returns that index. If the value is higher, then low is equal to low plus 1. If it is lower, then high is equal to high plus 1. That's plenty to explain. Explain the function of each of the search techniques. Like I've seen questions before in previous past papers where it's 8 marks to explain a binary search. So this one is 4 marks. So I'm not 100% sure what they want, but I know the core concept is sort the array first. After you sort the array, then you want to make sure that you're and then what? It repeats this. Until found or low is greater than high. I ain't taking any chances with this question. It's 4 marks, but just explain the whole binary search one time, as if you're doing it for 8 marks. It will save you a lot of trouble. Alright, consider the following array ARR. Write the C code to store and then sort the values in the array using a simple selection sort. Selection sort code for 12 marks. What? Yep. Told you all there was a storm coming. This is usually tough. Alright, so with a selection sort, you basically want to have some variables. You need to keep track of the minimum ID. you do your outer loop and then you do your inner loop. You compare the minimum ID with the one that you're on, whichever one is smaller. You swap them and then you. Alright, so now you write the C code for it. Hashtag include stdio.h. This is why, you know, sometimes you just have to write your answers in pencil because, yeah, you could mess this up. Right, if you cram this off, you should be okay. You should just be able to cram off a selection sort and write it out from memory. You don't have to reason it out because there's no drama here. Alright, so we're going to create the array int arr. How much spaces we have? 6 locations. So we have 6 possible spaces. Open brackets 3, 12, 9, 10, 5, 4. That will store everything inside the array. And right now we have to create a variable. So int. You have your outer loop, which is your I loop. I is equal to 0. Then you have your j loop. J is equal to 0. Then you have your minimum min ID. Just set everybody to 0. And what else we need, boy? Oh, we need a temp. We need a temp because you need a temporary value. And it's numbers we're dealing with, so everything will be integers. Right. So let me see now that right, so we set up everything there. Now we have to create our for loop. So the first for loop will be an I loop. For I is equal to 0. Yeah, because we start in our location 0. And then you want to go, since they hard code this and we know it's 5, we will want to go to I less than 5 and I less than 5. Now, I less than 5 means that you're going to stop there. Why we have to do that? It's because we comparing, it should be I less than 5. Oh wait, the array is not 1, 2, 3, 4, 5, 6. Yeah, 6 right there. Should be I less than 5. Or we want to go from 0 to 5. And then we want to go I plus plus FOR. That's supposed to be a R. 4, right. Alright, so we're starting off our for loop now, and our for loop is going to jump straight into. No, we can't jump straight into the next loop. Right, we want to now say, let's go with set minimum ID. Min ID is equal to the first value of the array, which will be I. Right, so we basically pulling out this minimum ID as the 0 there, so that we know we have to stop. Right, after you get our min ID is equal to I. The reason I'm doing it, reasoning it out, is because some people not good at cramming it out, so I'm trying to do the reasoning so that you will understand, and at least if you didn't know how selection sort works, now you know. Right, min ID. Then you have to start in next loop now. For J is equal to J has to start at the second variable. So J for J is equal to I plus 1. The reason we're doing I plus 1 is because you really want to compare with the second value, not the first one. So we really want to start the comparisons with the 12. J less than the maximum value, which is 6. Yeah, j less than or equal to 6. That means it'll go up to the fifth value. Yeah. Right, j less than 6, and then we go j plus plus, right? So this second loop now is where the magic going to happen, where we're going to actually jump through the array and see if there's anything that is smaller than the minimum ID. So we start in our for loop here. Next, what we're going to do, we're going to say if ARRJ is less than ARR min ID. Right, if the value that we jump to is less than the min ID, we'll have to swap, right? But we want to keep track of the new small position, the new minimum ID. So if ARJ is going to write, so min ID will be equal to J, right? So what we're doing here is we're keeping track of, okay, if we do find a smaller number, keep track of that index. Once we could keep track of the index, we have some hope in life. So this for loop will keep going on. Once this for loop is finished, you will do a swap. So we end this internal for loop, and now we're going to swap it. So we're going to say temp is equal to ARR I at that point in time, whatever I is, and then we're going to say ARR I is equal to ARR min ID. We'll swap those two, and then we're going to say ARR min ID is equal to temp. And then we close off this loop here, and boom, we're done. Did I need, I didn't create a main, sorry. That's tough, yeah. All right, so we get the main there, so then we close off the main here. All right, so now we double check this. 12 marks for your money. We create the array with all the things. Good. We declare all the variables that we need. We set up a for loop that goes to the second to last value because we can't compare past the last value. We take the min ID as the first, as whatever I is at that point in time. Then we create the next loop now, which will start from I plus 1, which will go to the second value. And the second value could go all the way. And we put the 6 here because 6 is the highest amount, but really going up to index 5, which is the end of the array. If the value at location J, wherever J jump to, is less than the value that is at the min ID, we keep track of the min ID. Because the min ID could become anything at that point in time. Once that's done, you swap the two, and boom, yeah. Right, good. That's that. Alright, part C. The following 10 integers are stored in the array data. Describe how the binary search algorithm would search the array data for the key 16. Describe, they say. Alright. Okay, so the first thing that will happen is we have 9 integers. So 0 plus 9 is 9. 9 divided by 2 is 4.5. So 4.5, when you cut it in half, will be 4, right? Because whenever you calculate in the mid, you will just take up the decimal, and that's the middle point, right? So the midpoint is 27. So you will say 0 plus 9 equal 0 plus 9 divided by 2 is equal to 4.5. So mid is 4. Then you say 27 is compared with 16. Come on, no match. 27 is bigger than 16. So low is equal to low plus 1, which is 5. Right, so low changes to 5. So now we're cutting off this part of the array and that part of the array. So we have now 5 plus 9 divided by 2. 9 and 5 is 14. 14 divided by 2 is 7. So our new midpoint is 7 equals 7. So mid is 7. From there now we want to say that 51 is what we're comparing to. So we say 51 is compared with, oh shucks, no. No, my bad. Let's dial it back there for a second. Sorry, my bad. Mistake. I went the wrong way. 27 is bigger than 16, so you want to say high is equal to high minus 1. Which is 3. So essentially what we're doing is we cutting off this part of the array. Right, which is 3. Right, so then we have 0 plus 3 divided by 2 is equal to 3 divided by 2 is 1.5. So mid is 1. Right, good. So mid is now 1, so we're going to compare the 9. So we say 9 is compared with 16, no match. We're going to say now 9 is less than 16, so low is equal to low plus 1. So now low becomes 2. Now we have 2 and 3, so we have 2 plus 3 divided by 2 is 5 divided by 2 is what? 2.5. Yeah. So then you want to say mid is 2. Right. Mid is 2, so we're comparing 2 with 16. So we say now 16 is compared with 16, and we will say match, and we'll say return index dose. Whew. That's plenty for 6 marks, but they gave plenty lines, but that's good enough. Once you could show that you calculate your high and lows properly, should be good. That's it for module 1. You're welcome. Alright, it's that time of the year again where it's time for crash courses, because you spent your whole year fighting up at school, not being able to go to school when you want to, always worrying about COVID, all kind of issues. So I have all the CSEC IT, CAPE IT, and CAPE Computer Science crash courses that you need. I'll be able to give you the whole syllabus in one quick dose to be able to get you over the hump. So here's how the crash courses will be going this year. So for all the crash courses, we have 3 different levels that you could choose from this year. Level 1 is video only. That's just a video that'll be about 6 to 8 hours long that covers the entire syllabus, going through in a kind of like a speed run, explaining every single thing, but not explaining every single thing, if you understand what I mean. Level 2 is a video and a class in April where you get to ask me anything about the syllabus. So you'll get the video in advance, you could watch it about 2 to 3 days before, and then you come to that class and then you ask whatever question you need to ask. And the third one is you get the video, you get that class, and you get access to our WhatsApp group directly to be able to ask me questions at any point in time whenever you're doing any past paper, whenever you're studying any work. And that's how the crash course is going to run this year. So the crash courses will be CSEC IT, CAPE IT Unit 1, CAPE IT Unit 2, CAPE Computer Science Unit 1, and CAPE Computer Science Unit 2. Those are the days. Each one runs from 9 to 12. That's if you take the class option. You will be able to come into that class and ask any question about the syllabus, and of course you will get the video a few days in advance where you could watch through the whole thing. So what are the costs? Well, for all crash courses, CSEC and CAPE, Basic, which is the video alone, will be $150. $200 will be for the standard, and the Pro will be $250, which is the video, the class, and the WhatsApp group to ask questions at any point in time So how do you register? You have to makeITsimpleTT.com/crash course, and you will be able to see all the courses that are available. You choose the one you want, you register, go through the payments, and then you will be given the video. Once you're given the video, you will be able to watch it at any point in time. Of course, if you register for the other ones, you'll be given the video and you'll be given the timetable of when your class is going to be. You'll be added to a Google Classroom. And if it's a pro, you'll be given the video, you'll be given the class, and your phone number will be added to our WhatsApp group. So that's makeITsimpleTT crash courses. So I look forward to seeing you all. April, everything is going to be launched, so you can register from now, which is from March, for them. And you might just get the video before the end of March. And just in case you're wondering, these crash courses cover the new syllabuses. So the new syllabus for IT CSEC that launched a few years ago, the new syllabus for CAPE IT, and the new syllabus for ComSci. All the new stuff, all the things that they put into the syllabus that may not be always clearly explained, or the current textbooks don't have it, these crash courses have it. makeITsimpleTT.com/crash course. So I'll see you all there.